Whoa, the light from outside your window just got brighter. It's 9:30 in the evening, and you have a huge exam coming up tomorrow. You peek outside to see if your neighbors use their floodlights again. But they're outside looking up in the sky. You stick your head out and notice that the moon got a lot bigger, double in size. You run outside and ask people what's going on. But they don't have a clue either. You take a picture of it and post it on social media. You view your feed and see that everyone is talking about it. The dark sky is brighter because the moon has more real estate to reflect light from the sun, making the light more intense. You can feel a slight imbalance while walking. Every time you take a step, it feels like you're walking lighter than usual. Because the moon became so large, its gravitational pull became stronger, so gravity became weaker. Suddenly, you look below you and feel your socks are wet. You run and hop on the top of a car and see that there's water flooding your neighborhood. Everyone tries to find higher ground or run back to their houses. This isn't a fire hydrant that busted and is spewing out water. This is ocean water seeping in. You're confused and lose your balance. You slip and fall in the water as it rises. Some people are in their cars, but they can't drive anywhere because of the water. You live near the ocean, but there has never been a tsunami or any flood reports in your whole life. There are no reported earthquakes around the area, so something strange is happening. You run back to your house, trying to see if you can get out your old inflatable raft to help you with the flood. The only problem is that you need to inflate it but don't have your pump. You inflate it with your mouth at first, but it'll take forever to pump it up. You search around your house for an alternative and find your hairdryer. You plug it in and inflate the raft as much as you can until you use your mouth to do the rest. The water level rises by every second and has now entered your house. You pack up a bag with a good flashlight, some food, and thermal blankets. You go downstairs and see that the water is now at your knees. You keep walking until you reach the door. When you step outside, the water pushes you left and right since the waves are very harsh. Since gravity has changed, it's not easy to swim around. You get your raft ready and use it to float yourself down the current in your street. It doesn't help that the water is freezing, and you're in the middle of February. After a while, you reach the highway where water is coming directly from the beach. You manage to get on a high surface and take out your phone. You kept it in a protective compartment in your bag for safety. You only have 15% battery left, but you brought your power bank. You call your family to see what's going on, but they too have no idea. You venture into the forest and try to spot an old cabin you used to visit as a child to see if you left your old bicycle there. After a few minutes, you find it and bike across the mountain to escape the flood. You can't seem to balance yourself since the gravity is affecting you. Some scientists sit around with laptops and spreadsheets, attempting to understand what's happening. Everyone is shouting and throwing out random solutions, but nothing seems to make sense. After a while, the head of NASA decides to launch an unmanned rocket to the moon. The rocket is ready in a few hours, and everyone is awaiting orders. 3, 2, 1, blast off. The rocket soars in the air and approaches the moon. It exits the Earth's atmosphere and travels at full speed in that direction. After a day or two, everyone gets live footage of the giant moon. According to the studies, the rocket can't be too close to the moon since it may have a stronger gravitational pull. However, the footage shows that tiny particles are floating around it, similar to Saturn's rings. These rings look like a giant disk surrounding the large planet, but up close, they're just particles that are the size of rice grains to the extent of a large bus. They're orbiting Saturn because of the gravitational pull. The images show that these particles are big and small, which doesn't make it safe for the rocket to get any closer. So it suspends itself nearby to orbit the moon and unleashes a mini-rocket that looks like a drone to get closer. The particles are many miles thick, making it difficult for the mini-rocket to maneuver. It flies closer and the particles start crashing on it. It's a good thing that the mini-rocket is durable for this. The rocket finally gets past the particles and lands on the moon. Gravity has gotten stronger since it inflated in size, which almost broke the rocket. As soon as it lands, another robot pulls out and starts driving around the surface, trying to get some clues. As of now, nothing is happening. but they're noticing some quivers coming from deep inside the moon. The moon's core is reacting abnormally. It looks like it's getting bigger and bigger. Scientists don't know if it will stop growing at a certain point, so the only way to find out is to drill a hole deep inside to uncover the reason. You're pedaling away and reach the other side of the mountain. The ground is shaking, and your balance is getting worse. You look across the mountain and see that the whole other side of town is flooded. You get your raft and supplies and make it there. You find a rowboat and paddle as fast as you can until you reach the lighthouse. From there, you can try to find the NASA station. Suddenly, you see a large rocket erupt from the ground and into the sky. You know for a fact that your brother is there working, but cellular networks are down. You paddle your way there for safety. The little rocket that landed unleashes a small drill strong enough to go miles to the center. It'll take days for it to reach down. So NASA is already launching another rocket to fly off and bring a bigger drill. The only problem is that the moon is getting bigger, so the particles around the moon also gather a lot more. The moon is reaching the Earth's size, getting bigger by the minute. The flood could reach several coastal states, and many micro-islands could be submerged, so it needs to be prevented.
A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. Mathematicians claim white holes might exist. Unfortunately, scientists haven't found one yet. Even if you saw a white hole, you wouldn't be able to enter it from the outside, but you'd notice light and matter leaving it. Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could already be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness in April. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. Our Milky Way galaxy and the Andromeda galaxy, our closest neighbor, are going to meet. But it'll happen in about 4 billion years. When they collide, an enormous elliptical galaxy will be formed. There might be more water on the moon than scientists thought before, and not only on its dark side, but also its sunlit side. This water is likely to come in handy during the already planned missions in the future. Cotton candy exoplanets are particular planets outside of our solar system, also called superpuffs. They have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, these planets are enormous. The Juno mission has noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet. These are 2 kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at a height of 60 miles above massive thunderstorms. In the universe, there are not only dwarf planets, but also dwarf galaxies. They have from 1,000 to a few billion stars. For comparison, the Milky Way galaxy is made up of 250 to 400 billion stars. A storm the size of our planet keeps raging on Saturn. It's called the Great White Spot. The storm has a tail of white clouds, and it encircles the entire planet. The storm occurs every 30 years or so, when Saturn's northern hemisphere tilts toward the sun. At first, the storm is indeed just a spot, and then it starts stretching in length. That's because the Great White Spot is a huge system of thunderstorms. But the main mystery puzzling astronomers is where the storm gets its energy from. Some scientists think it might be powered by the sun. Others disagree. They say the storm's cloud pattern only makes sense if there's an internal heat source that can power the winds. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also very hard to find. Rogue planets don't produce light. Neither do they emit heat, which means they can't be seen in infrared light. But not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. The Moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the Moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. Scientists often discover strange things in space. Many of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They aren't the remains of supernovae or a bizarre optical effect. Some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between black holes. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our sun produces in days, but last for mere milliseconds. Most of these fast radio bursts came from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source was a magnetar, just 30,000 light-years away from our planet. Any liquid floating in outer space forms itself into a sphere. This phenomenon also occurs in low Earth orbit. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. Astronomers saw the star for the last time in 2011. They decided to examine it more closely several years later, but it was already too late. The sun isn't technically the center of our solar system. It's in a space called the barycenter. It depends on which planet you're standing in. The barycenter is usually closest to the object with the greater mass. So, since we're on Earth, the true center of the solar system is the sun, but not the center of it. With respect to Jupiter, the barycenter is actually outside the sun's surface. Jupiter is 318 times bigger than Earth, so the balance is different. The planets don't really revolve around the sun, but around their common center of mass. Imagine balancing a pencil on the tip of your finger. You'd have to place it right in the center so that it doesn't tip on each side. Because the pencil has its mass equally distributed, it's easy to assume that everything balances its way like that, especially in outer space. But try balancing a hammer on the tip of your toe. Chances are you'll walk out of here with a broken toe. Its true barycenter is close to the hammerhead rather than the actual center where you'd grip it. Earth and the sun's barycenter is like that hammer. The center of mass is more or less in the center of the object. Realistically, if the sun were to rotate around Earth, then our little blue planet would have to be just as big as the sun, or bigger. We can't disregard the other planets in our solar system, which means they all will have to rotate around us as well. But in the ancient days, bright minds always thought everything revolved around the Earth. They called this the geocentric model, and this made sense to them because it looked like everything above us was spinning around us. The sun and the moon played vital roles in human history, and we didn't feel insignificant in the universe until way later on. In ancient Greece and the Middle Ages, the big brains used the geocentric model to study space. It wasn't until the 16th century that model changed. Back in those times, They couldn't even imagine that everything revolved around the sun, and they didn't have the knowledge to back any of this up. The Earth can't be the center of the solar system because it's not large enough for the job. For the conditions to suit the enormous size, life would have evolved differently. We'd probably be less dependent on oxygen. Some animals, like whales and dolphins, can stay for hours without taking a single breath. They can even sleep underwater. So the humans of the sun-sized Earth would have specialized lungs and wouldn't need to constantly be taking in air. It means that the plant life would be limited, with just a few shrubs here and there. There are trillions of trees around the world, but the main contributor to producing oxygen is the algae in the ocean. With such vast real estate of oceans and seas, the algae sitting on top are pumping out the air we breathe. Oxygen wouldn't be so abundant on this planet, but our breathing mechanisms might rely on carbon dioxide, another common gas found on other planets. If the planet is hot, then water will be scarce. We would only find it on certain parts of the planet, like mountaintops. The ground would be too scorched for anything to survive in properly. We can forget about seasons as well. The sun is currently just large enough to give us what we need. But since the Earth would be so large, and the sun would be another celestial body emanating heat, we'd always feel like we're inside a microwave. The days and nights will be different, and not much precipitation will happen. With so much heat produced in the core, earthquakes and volcanoes would likely erupt all the time. The surface would practically be a scorching plain of red magma floating around. This would be the true red planet. But if we had the same landscape like on Earth, living somewhere near the mountains could save you. The mountains would still be embedded in the core, but it would be better than staying on the ground. Some of the mountain peaks could even be 100 times taller than Mount Everest. The canyons could be so deep that the Mariana Trench would feel just like a little rupture. Animals would also behave and look different. Cold-blooded animals would have to soak up as little sun as possible so they don't burn. Animals would have to rely on migration to find water in distant lands. Birds can fly for hundreds of miles for migration season, so we'd probably see certain sleek-looking birds speeding through the air. But because gravity would be so strong on the colossal-sized Earth, the flying animals would need thinner bones and a thinner core just to take flight. The real survivors would be the microorganisms. They can live in extreme temperatures and pressures and can live without oxygen for a good while. The nights would be dark since there wouldn't be any moon to reflect the sunlight. The moon would most probably be on the opposite side of where the sun is shining, so it would forever be a floating ball in the sky. The Earth's rotational speed is the fastest at the equator, so if all the planets and the sun rotated around us, then our rotation wouldn't be so significant. New weather patterns wouldn't be good for crops. Humans would have evolved differently from what we are like now. We'd probably be shorter and stockier since gravity is so strong. And because of the soaring temperatures, we'd probably live in caves all around the world. The strongest ones would have migrated to the mountains. We'd probably have the same evolutionary path as we do now, but other physical features might be different. Our pigment would likely look different to combat the heat. The desert fox has large ears for hearing out predators and for cooling itself down in the scorching desert heat. It's possible that we would also have bigger ears than what we have now for the latter reason. We'd be a lot stronger than we are, and our bones would be thick and tough to break. Gravity is one of the key components to developing our bone density and muscle mass. This means we would unlikely need tools for hunting. This would have delayed the Bronze Age and modern civilization as we know it. Of fire and smoke fly upward, and the rocket launches. The Delta IV Heavy is one of the most powerful rockets people have ever made. 3 massive engines burn tons of fuel, helping the spacecraft gain altitude. The 2 side boosters undock, leaving the common booster core for further ascent. When in orbit, the rocket releases its payload. This is the Parker Solar Probe, the first spacecraft to touch the sun, and we'll follow its journey step by step. The probe was launched on August 12, 2018, and began its journey toward our star. The sun is 93 million miles away from Earth. That's 390 times the Earth-Moon distance and 36,000 times the width of the United States from coast to coast. The particles of light that the sun emits need 8 minutes to travel this distance. For our conventional rockets, that journey would take more than 200 days. But the Parker Solar Probe covered it faster, using gravitational maneuvers. On its way from the Earth to the Sun, the probe circled around our neighbor, Venus. All it had to do was enter the planet's gravitational field and let it attract itself. At this point, our space probe got an extra boost, and it didn't need to waste any fuel. After making one orbit, the space probe's engines changed the trajectory, and the probe left the orbit of Venus. It got enough acceleration to travel to the Sun. And on November 5, 2018, the Parker Solar Probe made its first approach to the Sun. Before touching its surface, the spacecraft had to enter the star's orbit first. To achieve this, it did even more gravitational maneuvers. Only after that did it start circling the Sun, the heaviest object in the solar system with the most powerful gravity. So, it'll give the probe an incredible amount of acceleration with each flyby. The Parker Solar Probe was constantly moving between 2 points. Those were the perihelion and aphelion. Look, here's the Sun, and here's the probe's orbit in the shape of an ellipse. The closest point to the Sun is the perihelion. The Sun was pulling the probe there at an incredible speed. At this point, the probe began to move away from the star. It still had a lot of speed and energy, but it was struggling against the gravitational force of the star, so it gradually slowed down. The point where the probe lost all its acceleration is called aphelion. The star's gravitational force won, and the probe began to move back toward the Sun, picking up speed again. The probe made several circles following a stable orbit, but then its orbit intersected with that of Venus again. Another gravitational maneuver, and after that, the Parker Solar Probe's trajectory shifted slightly, and it gained more speed. The perihelion point of its orbit was now closer to the Sun. The probe made several more circles following this new orbit. Then again, it neared Venus. Another approach to the Sun. Each encounter with Venus corrected the probe's trajectory and gradually reduced its distance from our star. In April 2021, the Parker Solar Probe finally came so close to the Sun that it touched its corona. Although the actual distance between the probe and the Sun was 5.3 million miles, that still counted as a touch. Let's look at the structure of our star by cutting it in half. This is the core of the Sun. It's about a quarter of its width. The core is 150 times as dense as water. Because of the intense pressure and high temperature, nuclear reactions occur there. Hydrogen gets converted into helium, giving off an incredible amount of heat and radiation. The next layer is the radiation zone. This is where the heat is transferred from the core to the next layers. But the photons here don't move in an outward direction. They can be directed anywhere and re-radiated many times. Scientists believe that the average time it takes a photon of light to travel from the core to the next layer of the Sun is about 10,000 to 170,000 years. Then there's the convection zone. This is what's considered to be the surface of the Sun. But it's not a solid surface. It's an ocean of hot plasma. It looks like a bee honeycomb. That's because the heated plasma rises from the lower layers, creating something like mini geysers. And while it's still hot in the middle of those geysers, their edges cool down, creating an amazing pattern on the Sun's surface. The next layers are the Sun's atmosphere. First, the photosphere. This is the layer that gives off light. And that's exactly what you see when you look at the Sun. But careful, don't do that. You need special equipment to look at our star. The photosphere is up to 250 miles thick. This is about the height at which the International Space Station moves above Earth. Then, the chromosphere, or the sphere of color. This layer of the Sun's atmosphere gives the star its reddish hue. Solar prominences appear here. Those are powerful emissions of matter leaving the surface of the Sun. Their speed can reach 430 miles per second. At some point, they get caught by the star's magnetic field and pulled back. And then there's the corona, a gaseous envelope of the Sun. The most powerful ejections take place there. You can see the corona during eclipses, when the moon covers the solar disk. Then you can notice some kind of glow around the star. This is the corona. It extends for millions of miles around the Sun. And the Parker Solar Probe touched precisely that area. That's where solar material and radiation are still tied to the star's gravity and don't fly off into space. And all that is beyond that area is the solar wind. It's the material and radiation that managed to escape the sun's gravity and set off into space. The Parker Solar Probe surprised astronomers by providing more information about this boundary. It turns out it's not a perfect circular wall like we used to think. The boundary is broken and uneven. It looks more like a mountain range. These bumpy regions have such a shape because of the uneven flow of plasma from the surface of the sun.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.